Thank you. So I appreciate that so many people stay here. So I guess that you are really interested in the topic, and I hope it's valuable for you the next 25 minutes. So yes, we are from the Austrian Research Institute of Technology. We are a research institute in Austria, and we are at the Center for Technology Experience. So my name is Helmut Schrom-Feiertag, and I'm working in the XR development sector, so especially for XR as training and prototyping environment, and use that also like to enhance industrial things, also like not only industrial but also workplace safety in that topic. And I will give in the beginning some more general approaches and topics we are doing, and then I will hand over to my colleague, so he will present one specific use case we did with Strabag, and give him the floor for a short invitation.
All right, thank you. So to close off the introductions, my name is Alexander Mirnik. I'm an interaction researcher. As my colleague just said, I will tell you about the BuildsaVeR project afterwards, and to give a little bit of a background. So what we are telling you today is a fraction of what we're doing. What we're also doing is we're doing interaction research for automated systems, so production lines, but also automated and semi-automated machines in construction or other dangerous or critical environments. And what you can see here is an excerpt from that and what we do. But more about after the general introduction.
Okay, yeah, then let's dive into it. So why workplace safety matters? So there is one special aspect, so that many accidents happen on construction sites, and they have all real matters, so they are quite serious. So as you can see, there are human and financial costs. So if there's an accident, you will lose workforces, and then also like will delay your finalization of the project. This is one thing on that mind. And also, like as you say, there are some studies out there as 25% of fatal accidents are resulted from losing control, so how operating things, and also like 22% are happening on a construction site. Another point is like it's not usual workplace, it's a high-risk environment. So that means people need to be aware about these dangers, and that is like how that needs to be instructed, and also like they are special, unique hazards for each site, so they need to be introduced in that. Another thing is like common causes. So as each site has its specialities, there are common things they are leading to accidents. So not enough training, not enough prepared or safety material used on that. So this is a point that could be taken together as a general approach how a training could be designed, which are these base elements. And fourth, it's like the regulatory pressure. So if a workplace is critical, so safety measures has to be taken into place, and that's why everybody needs a safety instruction before he can work on this site. And from the traditional training, so what are the main issues is like, the lack of engagement, classroom sessions, PowerPoint, so after 5 minutes everybody's losing his concentration, and after training they don't remind anything on the really important things, so the inability to simulate real dangers. You're sitting in the classroom and hear and see pictures about that, so it's not really that what you perceive then and what you take with you on the work construction site after that. And so that is like they are unprepared then for the emergencies that could occur. And another point is like the limited feedback they get. It's like a one-way experience, like somebody's talking something, at the end they have a questionnaire, and then that's everything on that. And it has in total a short-term impact. So after they did this training, so they really forget things very fast. So what you need to know about XR, especially I think everybody knows a lot of XR already, but to keep in mind, so extended reality, we are talking on different things like augmented reality, virtual reality, mixed reality, and they have different fields of application. So it depends how strong you want to blend physical and virtual worlds. If you want to stay only virtual, or you may overlays, digital overlays in the real environment, or you have more or less a virtual environment and want to have some physical aspects in there. So this is the, let's say, the transition from absolutely virtual to the physical world. And the difference is like how that enables you an interaction with real systems in the domain, in the real environment. The key features is like the immersion, as we'd prefer. If you have a PowerPoint presentation showing you dangerous situation, maybe you recognize that. But if you're in the situation, like immersed in that, it gives you quite another feeling about that, about the danger, and you can interact that. So you can set decisions, you can set actions, and then see what happens on that. So you also can learn if your actions are right or wrong. And then it's also like a realism. The more complex simulations behind that, they give you a real experience that you are there. And the main application for that is like training and simulations. Could also be used as a remote operation for some parts, or you do like design prototyping or the entertainment and design. So these are the main things there. The key benefits are, as we heard, it's immersive. You can simulate a real hazard situation, but it's also like an engaging learning. So people don't sit anymore on their place, so they really do things, they experience, they have like this spatial awareness about that, and also like that improves the learning retention. So after the training, it has shown up that they have a much higher retention compared to other trainings. As you see, engagement retention, there was a study, 94% of the training reported a higher retention after that. And also it's highly scalable and long-term savings on the costs. You don't need a trainer for everybody. Multi-language could be an issue, and it's ready to go. And the one thing is like you can really simulate risky situations, especially the ones they appear at your special construction site. So limited spaces, different machinery, things, and how you can operate in that site. And it's personalized and adaptive. If you do the training, you know how good you were, and then you can repeat the lessons that were necessary to be repeated. So you have a feedback, and you can adapt the training according to the needs, what people don't know on average, but also like on a personal level. So what we also doing is like, I give a general overview on what training is used at AID. In the project, the Horizon project, MedFirstMR, we were using it for medical training, so train people for mass casualty incidents. You have a lot of victims, and you have to decide, doing the triage, who needs support first, and do that in a group training. And this worked quite out very well in that use case. Another use case is like FW Safe XR. That is like a safety training for forest workers. So how you operate machinery, but also like how you save the space if you cut down trees, and what will be possible accidents, or how you, if there was an accident and there is a helicopter coming, how you communicate with the helicopter that he should land here or where else. And at the end, we have also like a cranium where you make operation training on a crane. So that also like simulates you. We have a seat there that makes it shake it as realistic as possible. If you're sitting in the crane and operating the crane, and get awareness about the difficulties, also like the accident situations that could happen on that. So, and now let's go to a use case, especially for Strabag, and hand over to my colleague, Alexander.
Thank you. All right. So now that you've had the general umbrella of what we're doing, let me provide you with a concrete example of one of the projects. So it's called BuildsaVeR, and the context of BuildsaVeR is workplace safety, especially in relation to heavy machinery. And now you might be asking, what specifically is the issue here, or better, why do we need XR for that? And in order to answer that, so I've put up let me see if the laser pointer works. Oh yeah. So I've had a very different picture on this slide originally, but when I walked here to this venue yesterday, I saw what you can see right here, and I thought this just exemplifies what the context is so much better than anything we had here. So what you can see here is a crane extended all the way to the top. There is no railing of any kind, and then you see here a cyclist crossing while stopping by, almost touching this one. I would now ask you, is this safe? But I don't even need to ask you. You know, this is unsafe to a certain degree, right? And the question is, why is that the case? Do they not know? Of course they know. These people are highly trained. The company is also very, very behind safety initiatives. They know what they're doing. So what is the issue here? Well, the issue here is putting theory into practice, and that is something the company had recognized and what they wanted our help with. So they understood, or they knew, well, we have the safety training. They sit together with the safety trainer. They get those 2 or 3 hours of training. Then they get a briefing when they're on site, on the construction site, and that's it. What is lacking is routine. They need training, but you can't really do it. You can't train accidents on site because you want to prevent them before they happen, don't you, right? And so you can probably already put 2 and 2 together and see how that works out. And so what they wanted us to do is to devise a training system application for them, so in order to help with that. And what you can see here is some of the initial, very, very initial sketches that we start out with, and from there you can see how it worked out in the end. So more specifically, what is BuildsaVeR? So it is a simulation, and most importantly, the aim of this simulation is not to be the most high fidelity, high spec simulation, right? So you'll probably will see or have seen better, more detailed modeling of environments, but the goal here is really to have as realistic as possible simulation of the construction environment so that you can then simulate actually realistic encounters as they happen and then teach the participants what proper behavior is through exercise, repetition, and then teaching them how that works, which translated into 3 specific goals. So number 1 right here, one is increase the safety awareness, right? It is one thing to acknowledge something, it's another one to understand something. If I sit in the safety briefing, I might acknowledge the rules, but I probably haven't understood those unless I've been at a construction site under all the contextual influences, right? It is loud there, it changes from day to day. The machines that are there at 10 a.m. will not going to be the same machines that are there at 12 a.m. and so on and so forth. So awareness, build awareness, maintain awareness, understand how that works, number 1. Number 2, then teaching the correct behavior. It is very easy to tell somebody, well, you know, if there is a machine over there, don't get too close. It is a lot harder if there is a machine there, there's another machine here, and there is a different machine there, people here, people there, and over there somebody's shouting at you, telling you, hey, come over here right now. But that is what behavior is all about. It's not, there is theory, yes, but behavior is really what do you do in the situation when you have no time to decide. And number 3 is then to foster a holistic comprehension. It's not just me, right? It's everyone else. It is not just right now. It is what happened before, what's going to happen afterwards, what's the construction site today, what it was yesterday, and what it's going to be tomorrow, so that you really understand how someone else's behavior influences others' behaviors and vice versa. So these were the primary goals. And our role, and I apologize for the wall of text, but I'll summarize this briefly. Our role essentially was to really go into the construction sites, to talk to the workers, talk to the safety experts, then derive what is really needed for the training, because it had to be condensed down, develop that training, devise the units, and then actually develop the whole thing in a very, very nice cooperation where they helped us out with the modeling, and then we did the programming and the division of the training modules. Oh, there we go. More specifically, since you have to begin and end somewhere, their biggest immediate issues were 3 specific working machines. These are the ones that you can see here, the road roller, the excavator, and the dumper, all with separate challenges. Now, what is important to highlight here, this is not a safety training for the machine operators. This is a safety training for those who work in the vicinity of these machines. But each of these machines pose different challenges and issues. And as somebody who has not or has never operated these machines, it is very difficult to comprehend these. The level of visibility on a roller is very different from the level of visibility on a crane, right? Because on a crane, if you sit there, you don't see very well to the right, because that's where the arm is, but you see pretty well to the left, versus on the dumper, you see super fantastically to the right and to the left, but you're at a far more elevated position. Now, as you, who is on the ground, you don't realize that unless you've been in that position. And who has time or is allowed to be and operate on these machines? Well, not in real life, but in VR, you can do that, right? And so you can see how that develops to a very, very sensible and meaningful application in a VR, or, well, I guess I should say XR environment, because that's the track that we're in here. But anyway, what the training consists in is 3 key clusters of tasks that encompass what is really necessary to foster the situation awareness. So I'm not going to bore you with the process, how we came to this, but this is what it was distilled down to. And what is interesting here, that one of the things that came out is that vehicle inspection, which is something that the regular staff never does at a real construction site, was something that was desired to be trained there for the regular staff so that they actually know what does it mean for the vehicle to be in safe operation, so that you can see that from the outside. And then we have situation awareness, where you can foster awareness by enabling perspective switches, showing them what it means for this vehicle to brake versus that vehicle to brake. What does it mean if the arm of the crane is extended? What is its maximum reach? What is its average reach? How far can it swivel from one side to the other? And these kinds of things. And then number 3 is an actual application scenario where you get a very realistic task. It's not just, hey, let me show you this is what the area is. No, but your task is more like, take this object, take it to over there, and try to make it there safely, applying everything that you've learned before. So you have a very meaningful escalation of what is required of you and your understanding. And so, here you can see how that actually works in the VR. So again, this is nothing that's reinventing the wheel. It's more about the application case. And as you can see here, it ended in a very, very compact set of scenarios and how these are executed. Because the goal is also to have this be used for self-study. So the idea is that you, as the construction worker or prospective construction worker, right, you take the headset, you put it on, you do the training until you're satisfied, or your employer, depending on how that works, and you set it apart, and then you maybe do it again. Maybe you need a refresher a few months or so. And this is a very compact and easy way to do that. And also you don't need to do everything at the same time. Depends on which machines you're working with, and so on and so forth. And to really illustrate that for you, because I realize it is quite late in the afternoon, we of course have some videos for you to showcase how some of the things are looking here. So what you can see here is the vehicle inspection. So essentially what they need to do is go around the vehicle, and these things are not pre-signaled, right? So you check all the parts of the vehicle, and then you need to approve or disapprove, and then this is a specific part that they actually wanted. Then you go to the foreman, and then you check these off and you get your confirmation or not. And in the second part, you can see that for a different machine. And the learning content, of course, here is clear. Actually learn the significance of the checks, because that is also something that is time critical, right? Sometimes you come to the construction site, there is no time to think, I'm not going to do the checks today. And this is how they incorporate that into their routine. Then another thing for the situation awareness. So here you can really see where they can learn what it's actually like from the vicinity of the vehicle to inside, to really see, okay, this is my position that I was in before. This is how far I need to look in order to actually see myself where I was before. So to understand that visibility does not equal visibility, and it really depends on who you are. And the same thing with different vehicles, because what is the pivoting range of the crane is irrelevant to the dumper. For the dumper, it's much more important how fast these things go, because those are so much faster than any other vehicle on a construction site. That is also something that you need to understand. That is a very easy, natural, and immersive way for them to do that. And for example number 3, you can see the application scenario. Now this is for installation purposes, a simple implementation where they go from point to point and need to decide on their own. Can I go? Do I need to look? Are there any other objects or vehicles? And if there are vehicles, you could see it here. Do I need to establish eye contact? Which of course they need to, because otherwise they won't see them and won't stop in time. And this is another fantastic application for XR, because we can do that easily versus, well, how do you confirm that in a paper-based context, right? And you can see another example here where you have multiple vehicles, and I'm not sure. There should have been some gesture interaction as well, but I guess it was not in one of those. But if you stopped by our booth, you saw that as well. Anyway, the important part about this one, and what I hope we were able to show you with this one, is that it is often not so much about building the best, most sophisticated simulation, but in many cases it is about finding the right and proper use case for your application, which in this case really was the case, because we had a low-spec hardware target, right? We were specifically required to develop something that's not too fancy so that it runs. But there was a specific need where the client said, we need something that is not a standard desktop application. If you just put our text into pictures, that's not going to work. We need this immersive element because we need it to train. And this is why this is such a nice example, because there is, on the technical level, there is no reinvention of the wheel here. But on the non-technical level, there is a fundamental change, I would say, in how we can do safety training, and how the safety training, by applying something that already works, by making no technical leap, we can, a little bit of exaggeration for sensation, but kind of have a new era of how we do safety training by channeling the power of the XR. And that is something very fantastic, and also where I think it's very much worth sharing, that we don't always chase on the technical side, but also explore more on the application side and think of more a context that might not sound like the fanciest ones, and where we sometimes tiptoe around, right? Especially if it's safety critical, but where there is a huge potential and also a very great application viability for XR. And with that, I want to leave you with our final quote, or what if your employees could prevent accidents before they happen? Well, now they can. And if there is anything where you want us to help you with that, you can always approach us. And beyond approaching us, you also have 4 more minutes to ask Q&A right now. So I think we'll go to that. Thank you.
Thank you so much.